Welcome back, dear students. In my previous videos, I told you how to add two or more vectors. Today we will do the reverse. That is, we will break a given vector into two vectors. And the breaking of a vector into two vectors is known as resolution of the vectors. There are infinite possibilities, infinite pairs of vectors, the sum of which is the given vector. Just like a number can be broken into two numbers or expressed as the sum of two numbers in infinite ways. As for example, 5 is equal to 3 plus 2, it is equal to 2 plus 3, it is equal to 4 plus 1, 5 plus 0, 6 plus minus 1, etc. etc. So there are infinite pairs of vectors of which a given vector is the sum. So we will take only one particular case in which the vector will be broken into two mutually perpendicular components. That is, those two vectors should be perpendicular to each other, of which this given vector is a sum. Suppose this is the vector A and it makes angle theta with the x-axis. Then we will break this vector in two vectors, one along the x-axis and other along y-axis. This breaking is resolution of vectors into mutually perpendicular components. For that, what we do, from the tip of the vector we will drop a perpendicular on x-axis and a perpendicular on y-axis. Then you can see that this is one vector and this is the other vector, of which this given vector is the sum. This component, which is along the x-axis, is called the x component and is denoted by the letter ax, and this component is the y component and is denoted by the letter ay. So we can write a is equal to ax plus ay. This can also be written as a equal to ax I cap plus ay j cap, where ax is the magnitude of the x component of the vector and ay is the magnitude of the y component of the vector. If this angle is theta, then you can see from this triangle, let us call it PQR or PQS. Then from this triangle PQ, which is the magnitude of the vector ax, PQ upon PS is cos theta. It means ax upon a. PS represents the magnitude of the vector a. Ax upon a is cos theta. It shows that ax is equal to a cos theta. So if a vector makes angle theta with x-axis, then its component in the x-axis direction is ax is given by ax equal to a into cos theta. Now from this triangle it is clear that QS is equal to the magnitude of the vector component ay. So QS upon PS is sin theta. It means ay upon a equal to sin theta. Therefore ay equal to a sin theta. So the y component of the vector is ay equal to a sin theta. This way a vector is resolved into two mutually perpendicular components. If we square and add these two equations, we get ax square plus ay square equal to a square cos square theta plus a square sin square theta, or ax square plus ay square is equal to a square taken common cos square theta plus sin square theta. You know that cos square theta plus sin square theta is 1. So it gives us a square equal to ax square plus ay square, which must have been actually the case. Whenever two vectors are perpendicular to each other, they are added using Pythagoras theorem, as has been discussed earlier in some video. Now, if a vector is broken in a component which is perpendicular to the vector itself, that is, if theta is 90 degree. How can you understand it? Suppose a vector is along y-axis, then what will be its x component? In that case, we will write theta equal to 90 degree. So the x component of the vector will be ax equal to a into cos 90. Cos 90 degree is 0. In this gives us ax equal to a only, 0. It means a vector cannot be broken perpendicular to itself. Its physical meaning is that a vector has no effect in a direction perpendicular to itself. For example, the force of gravitation works downwards, vertically. It shows that this force cannot be broken into a component which is perpendicular to the vertical direction. That is, in the horizontal direction, the force of gravitation has no component. It means it does not affect any motion which is taking place in the horizontal direction.